Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I do data science and machine learning at Databricks. And I'm joined by my lovely co-host,
Ben Wilson. I write docs for my code at Databricks.
Beautiful. I think you reused that actually. So
Nah, it's like a variation, but it's
Okay.
what I'm focused on right now, so it's close to mind.
All right, we'll give you credit. So today we are speaking with members of the ML platform team at Lyft, Konstantin and Jonas. Konstantin has worked as a software engineer at Amazon, Instagram, Stripe, Facebook, and most recently, he's taken the role of senior machine learning engineer with Lyft, although he's had a couple other roles at Lyft before that. Jonas has worked at BMW, taking a variety of researcher roles, and then moved to Jelly. Am I pronouncing that correctly?
Jelly, yeah.
Jelly, cool. An energy management software platform where he worked as a software engineer. Now, currently at Lyft, he works as a staff software engineer for the ML platform team. And I wanted to start off with a very important question for Jonas. Before we get into ML, can you explain TNT robotic?
It's the robot soccer team my younger brother and I started. So the TNT is for Timmermann and Timmermann, our last name. And pretty much through all of high school, we built these robots that are I think they're kind of like 10 inches or so in diameter, and they play on kind of the size of our ping pong table. And we just went all over the world and competed in the Robo Cup and spent way too much time on it, kind of working on those robots all night.
And did you see success? Take home any championships?
We got pretty good at it towards the end, and we actually won the world championship.
Wow. How old were you at the time, out of curiosity?
We won it twice. I think the first time I was like 14-ish, and then maybe like 18-ish or so.
Cool. Well, that's kind of wild. I'm glad the glory didn't corrupt you at an early age. So, kicking off with sort of my first topic of interest, can you guys sort of describe the scale that you're working with at Lyft from a ML infra perspective?
I can give some context here. So, one thing that I found when we've talked to other companies that are similar to Lyft, like I don't know what I can name, but maybe like Robinhood or others like that, is that we actually have a lot more different teams using models. So I've heard from like similar companies of our scale that they have maybe like 8 models, 10 models, something like that. Whereas for us, we have basically like dozens or like multiple dozens of teams, maybe like 50 teams that deploy their own machine learning models in our infrastructure. And then in total, we have maybe around 400 models that are being used throughout Lyft for different applications.
And what are those models? Is it time series? Is it deep learning? Is it just linear regression?
We have all sorts. We have a lot of tree-based models. We have a lot of logistic regression models, neural networks, time series forecasting, things like that. Yeah.
So it's a distributed distribution of data scientists throughout the organization. Do you actually hire data scientists at Lyft and say, hey, you're working with this team that owns all of this data, and we need, build cool stuff that helps them do their job, and then they interface with your team to help deploy that and manage it? Or is it like just completely decentralized and those teams just hire whoever they need to and build whatever they need to?
I feel like our structure has changed over time, but in general, teams will have embedded data scientists, and then those data scientists work in more of a distributed fashion, and they kind of work with engineers on training and evaluating models, and then the engineers and the data scientists will work with our team to actually productionize the models and make sure that they're doing what they're supposed to.
Interesting point that you just brought up there. The data scientists work with the engineers. Do you find that that is from the other companies that you've talked to, and I'm not going to talk about my history in this, but have you found that some of those other, big name text, companies, that's a common pattern in them for those companies that actually produce a lot of models that are deployed to production?
So I think I've only worked on a platform at Lyft. So I'm not entirely sure if it's atypical for like data scientists and engineers to work as closely.
Ben,
Yeah,
what's
Jonas,
your
I don't know.
experience?
It's exceptionally rare, but it's something that I've mentioned to people in the past, that the companies that I've seen that are doing what you just described, Konstantin, with like, hey, we have hundreds of models potentially that are in production that are being used. Every single company that's like that has data scientists paired up with 1 to 5 software engineers. It's not the only thing that the software engineers do, but they're there to make sure that that thing is structurally sound, is deployable, is tested, and functions correctly. And then you have like an ML engineering or ML ops organization that's there to do the deployment and manage everything, make sure that you're doing A/B testing and that data is being collected about usage and metrics and stuff.
Mm.
The vast majority of companies out there, though, will have just a monolithic data science team, and they're like, oh, that's where the data scientists work. And then teams within the company will approach them to try to get their time and solve a problem. But when you look at the number of models deployed to production, where it's just a team of data scientists working on their own, it's usually from what I've seen, less than 10 like production things that are deployed.
Interesting.
Yeah, I don't think that would scale to the number of product teams and repositories and models that we serve. And I think the way we structure our model serving system kind of supported that deployment model also. Now, originally, we had a system called Model Exec, where we centrally developed this model serving solution, and ML platform owned it. And all the other product teams like pricing and fraud and whatnot, they would get an instance of that model serving system, but just there were kind of like small configuration adjustments that made it pull their models rather than another teams. But it was very centrally managed by us. It only had one deploy pipeline. It had one set of dependencies that everyone had to agree on. And it caused a lot of kind of conflicts across the teams, and someone would mess something up and the deploy pipeline is blocked, and the dependencies are even more critical because with the model artifacts, you might have a model from like 3-4 years ago that kind of ties you back in terms of the dependencies that you can use. So this was very painful, and we've gotten a lot of grief from the product teams. And we developed something called Lyft Learn Serving, where we basically turned this service into a library and combined that with a like repository code generator. And now each product team owns their own repository that is kind of like spun up with this code generator, and then they consume our core model serving capabilities that contain like model syncing, loading it to memory, actually the API endpoints of serving the model, and kind of all the observability aspects. So they consume that in the form of a library, but they have control over like when they update the library and things like that. And they can bring their entire own set of dependencies to the image that they end up serving. So they can pull in their own version of TensorFlow and whatnot, and they don't have to agree with the rest of the company, and they have their own deploy pipelines, and it goes to their own on-call and all of these things. So we are very kind of distributed ownership model for these model repositories, and that enables us to serve kind of a very large group in the company, and we have more than like 70 of these repositories as a fairly small ML platform team. So Konstantin and I are pretty much the only ones that focus on the online model serving side.
So it's almost like a plugin model where if they have a bespoke implementation that they need to do for inference needs, like say a new data type that you don't currently support, they can write a plugin on their instance, plug that in, it'll work as long as the code actually deploys.
Yeah,
Right.
that was like a huge feature that we introduced in 2021. So in the past, we kind of had our library of different model wrappers. And so it's like, let's say you want to serve a light GBM model. Our team has an implementation of a light GBM wrapper in Python. And then a data scientist or an ML engineer would install that in a notebook, train their model. And then with our Python wrapper, they would have an artifact that's servable. But then if these like data scientists or ML engineers wanted to do something different, they were kind of not really able to. Like they had to build a service which would like pre-process their inference call and then call into our serving system, or they would have to kind of like ask our team to modify one of the wrappers. And one of the big sort of like, I think, innovations that we introduced was we allowed teams to kind of like inject into their service model handler code. So then we still kind of used a well-defined interface. Like this is like, we have a dictionary that defines the types of features that you're passing to your model. But then from that interface, we kind of use to customer code that gets injected into our serving runtime. And then those customers can implement arbitrary transformations. And then that sort of goes to the underlying ML framework and the ML model. So that's
absolutely brilliant. I mean, like the same thing that we do, with our ML flow implementation with like custom PyFunk. We provide that layer of abstraction and say, hey, here are the conditions that you need to meet at a minimum. You can put anything else you want into that. We're not going to stop you so long as you maintain structure with regards to validation of the data types that are coming in. You can't do things that are sort of invalid for the model server to process. But anything other than that, just expose the abstraction to them. Do you find that it's easier? You mentioned that you expose something like a dictionary based, some sort of enumeration that you can pass in that defines those configurations. Do you find it easier to provide something like that to your clients, which are basically the data science teams, versus something that's more what a software engineer would expect? Like, hey, here's this just abstract base class. You implement your own class on top of that. Like, is there a reason why you would craft something in one way versus another based on the audience?
Is your question primarily about the interface, like why we chose to pass our features as a dictionary, or is it about like the model handler broadly?
It's more about like that team that's building a model when they want to, do that plugin approach and modify the behavior and how that configuration is passed to that. Does your end audience, does that inform your design at all for building tools like this?
I would say definitely. Like all of our kind of machine learning, data science facing code, it's like all Python, while like some of the other implementations are in Golang. And actually, most of our requests are just kind of HTTP based. We have some like protobuf support and whatnot, but I feel a lot of the machine learning components are difficult enough as it is that we don't want to necessarily introduce additional complexity on top of it. So if it's something that can be easily human readable, seen as kind of a request, we haven't really seen the need to kind of optimize for kind of machine execution or something beyond that. In terms of the interfaces for inference, we keep them very, very wide open. I'm not even sure if like the dictionary is enforced. I mean, it's kind of the type hint in Python, but I think you can basically dump anything in there and then in the model handler kind of make sense of that data. And what you mentioned with the base class is we actually use kind of like a mechanism for the model handler. So the model handler subclasses the generic model interface definition. So that makes it very easy to kind of override any of the capabilities, and we can register some simple pre-processing of like the features, but it's more powerful beyond that. Like recently we introduced some reinforcement learning models, and the way how that reinforcement learning library was integrated into our serving system was just through this model handler interface. So it just subclasses that model and overrides the way models are saved and loaded, and how the model scoring is implemented. And before, we would have had to integrate a new machine learning library into our ML platform library for kind of the whole serving system to support it.
Yeah, 100%. The only reason I asked all those questions was sort of a leading question, which is simplifying stuff for your audience and making it as approachable as possible is always a better solution, in my opinion. And keeping things where you wouldn't say like, oh, in order to build your custom model, we'll expose this abstract implementation that now you have to basically build this, flavor yourself, start to scratch for a data science team. That's so much extra work for them to do, and you get resistance from your users. They're like, this is really hard, and it's going to take us like 3 weeks to do this. Could you help us? But giving the tools in a very simple interface like how you've done makes it not just simpler to use, but also way more powerful, and people can move faster. So I think it's a brilliant design. A plus, guys.
Something we actually focused on is helping people generate a repo that serves one of these models really quickly. And so like there's a lot of boilerplate at Lyft, and I'm sure every other company, that you need to sort of like write to have a service, to set up your networking configurations, to set up your like Terraform and stuff like that. But what we used is we built a Yeoman generator where, like, let's say you want to build a new model repo for, I don't know, large language models. You would kind of like define that. You would create that repo in GitHub, and then you run the Yeoman generator. There's a few different parameters, and then you wind up with a repo that actually has this like base class implementation of the model handler, and it's pretty clear like where you would need to make changes to add pre-processing and post-processing logic. It has unit tests defined and integration tests, and so that really helps with making the whole system kind of easier to use, even for like more junior engineers or for data scientists that aren't used to writing code, because you basically start with something that's working, and then it's pretty clear what you should be tuning.
Yeah, that's really smart. I love that idea. Michael, please.
Yeah.
How does that to your customers?
Yeah, 100%. Yeah. So for reference, I build a lot of these sort of bespoke CI/CD and productionization solutions. But Ben, I was actually going to kick a question to you. How does this framework differ from MLflow recipes?
Not too terribly differently, but MLflow recipes, in order to implement, like what you said, you got a reinforcement learning working as like a new thing. That would require somebody to build that entire pipeline in MLflow recipes. That's a lot of work, like a lot of work, and that's templatized. But that's hiding the abstraction and the complexity from the user completely, because it's template files. It's a lot of config. It's like YAML configs. So that's one approach that you can use to simplify things for a wide, broad audience. But I don't think something like that would work for your users at Lyft. And this just goes to show, it's something that we've talked about on the show many times, about the most important thing is to listen to your users or your customers. And in the case of people that are doing infrastructure work, that's just talking to the teams and saying, like, what sucks about what we're doing, what could go better, and then going back to the table and having all the brilliant people that understand it, such as the two of you, come up with that solution. It's like, hey, let's make something that's really easy for them to use and automate away all of that stuff that they really struggle with. So now we have a stable deployment that we can be confident of as an infrastructure team, that like, hey, we know the tests are written because we wrote them. It's
Yeah.
just brilliant, like awesome.
Yeah, that beautifully segues into my next topic, which is what sucks at ML infra for Lyft. What do people complain about? What do you guys not like maintaining? What are the bad features that you're looking to improve on?
I have one thing that is definitely top of mind for us right now. So we started out and we built our own like Kubernetes cluster essentially to manage a lot of the stateful kind of like compute workloads that were needed for the MLP. And so these are things like training jobs, batch compute jobs, notebook pods, and stuff like that. And that's really like the component that gives us, I would say, like the most sort of like pages and like the highest operational burden. Especially because like, over time it's like it's been maybe like 5 years since the cluster was built or more, like since it was stood up. And then a lot of like the people that were more like, Kubernetes oriented, ops oriented have since left the team, left the company. And so now we have this like kind of like Snowflake Kubernetes cluster that our team is primarily using. And that's been something that we've like repeatedly tried to figure out how to get off of over the years.
And what stopped you?
That's a good question. I think part of it is that it seems like it's a large migration effort in general. We've kind of changed our operating model too. Like we're the ML platform team, and then at some point in the past, we found another team that was sort of like willing to operate that cluster for us, and so it was kind of like out of the scope of the team, and so effectively we were like abstracted away from the ops load. But then as the company's changed, like that component's like come back to our team. And so now we're kind of like looking into both like vendor options for some of those components, like notebooks, and potentially for training jobs. And then I think the whole company is looking at more of like managed Kubernetes solutions. So I think it's just a matter of time before we figure out the strategy there.
That makes sense.
Yeah, it's something that I've seen and lived through the pain of. I heard that story just now, and I'm like, man, getting flashbacks of pulling off the shelf open source tooling that it's super powerful, but in order to keep that thing running, it just takes so much effort, and there's always some edge case that like the fix isn't quite in open source, or hey, you know we're working on a PR for this, or you're filing a PR for this to fix, get that implementation working, and then something else becomes unstable, and then you have to stop your work because you got a Sub-Zero that just fired because hey, inference is down in these 7 regions, like these models are blowing up. What's going on, guys? Can you figure this out? And you're like, you're just in keep the lights on mode for months, and you start looking at your OKRs that are filed for the next quarter, and you're like, man, it'd be great if we could like do this feature development, but we have to set aside this time to keep this infrastructure on. I feel your pain, man. And from my experience, if you find a good vendor for that, like does that stuff for you, it seems like a huge cost at first. You're just like, man, this is so much money. But every team that I've worked with or that I've been on where we've made that decision, like, yeah, it's money, but the thing that's more valuable to that team is time. And if you can free up that time so that you can innovate at what your company is focused on, you're just like, this is so worth it, because we made what we're spending, given to this vendor for the next 5 years. We spent 3 months, did a project, and it already paid for itself.
Yeah, definitely. I think there was a period at Lyft, like probably around the time that I joined in 2018, where the company was really interested in like developing technology in-house. And so I think there's a lot of amazing examples of that came out of Lyft, like, Amundsen and
Yep.
Envoy and tons of things like that, Flight. But the strategy I think going forward is that we're primarily focusing on the business, like things that are like differentiated for Lyft. And so I think for a lot of the components that we built in the past, like if we were starting now, given how like the industry has evolved, we probably wouldn't build them in the same way, essentially.
Got it. Yeah, Jonas, you've been quiet for the what sucks at Lyft question. Is it because there's too many things to list, or because it's perfect?
There were a couple of things going through my head. I think our kind of like our core functionality works pretty fine. I think we have some kind of feature gaps. I don't think we have a good kind of experimentation tracking. So we have an environment to kind of kick off notebooks, and there's some kind of metadata tracking, but there's no good kind of like figuring out which data was used to train the model and kind of like go back. And I think we are also fairly light on kind of like our feature store capabilities. It's actually something that is also more managed by the data platform team than within kind of ML platform. And I think it does the job, but it doesn't have kind of special feature store capabilities beyond kind of just kind of storing the features and looking them up.
That makes sense. And have you guys looked to leverage open source solutions for this, or are you mostly in-house, or how are you thinking about developing it?
We've talked about it a couple of times that it's something we want to get to, but it's mostly a bandwidth issue. So it's like in all the like what we want to work on roadmap type of documents. I think it's more of a question of what we're getting to. But yeah, I think the team as a whole went through kind of like an interesting evolution where kind of a couple of years back, there were all these gaps in our platform, and kind of the customer teams would complain like, oh, this is not working, I can't use this library. And we worked hard on kind of satisfying those. And now we are kind of in an interesting spot where we almost have less kind of inbound requests from product teams like, hey, can you solve this burning need for us? But now we're looking like, oh, what could we work on that could be beneficial for the company? And we Konstantin is working on like real-time streaming stuff. We looked into embeddings, generative AI, reinforcement learning, and we kind of to some degree kind of move ahead to some of the product teams, and then have to basically look for customers for the things we build rather than how it was before, where it was more the other way around.
Seems like a fascinating place to be in data-wise for a company like Lyft, with the fact that, I mean, you guys have global data of human movement at your fingertips, of such data volumes. Because, I mean, how many? I'm not going to ask you how many customers you have per day. I know it's an astronomical number, but you have information about, concentrations of humanity, like where people are going or where they're coming from, and providing, some sort of retrieval augmentation generation in with that, where you can leverage one of these, super fancy, LLMs that are out there to, OpenAI ChatGPT-4 latest build, and then just say, hey, you have access to generate embeddings based on this question, and we're going to just embed all of our data that we have about this, these super wide tables effectively, and just vectorize that and embed it. The questions that you could answer with that data set that could inform the future of the business is probably staggering.
Yeah, and some are also just really interesting visualizations. One of our teammates, Adriana, worked on a embedding project. I think it was embeddings between riders, drivers, and places in San Francisco, and would just generate these heat maps, and you could kind of see like, oh, this is a driver that mostly drives on the weekend and kind of like it's like in all the party places to kind of get people home, or this is kind of like more like the tourist spots and whatnot. So yeah, tons of interesting data.
Got it. And earlier you mentioned that there's a bandwidth problem. So if you can't be refactoring your Kubernetes cluster or working on feature store, what are you guys doing day to day?
So for me these days, I've been mostly working on reinforcement learning, and there are kind of like different evolutions to it. So in the simplest form, we have these multi-arm bandits. So kind of fairly kind of the most simple approach to reinforcement learning, often used to run kind of more efficient A/B testing. So rather than splitting your traffic 50-50 between like A and B, you can use a multi-arm bandit, and it will learn that one variant will perform better than, or if one variant performs better than the other, kind of guide more traffic towards that variant, and you basically incur less regret of like directing traffic to a poorly performing variant longer than is needed. So the model will figure out, okay, this one performs better. And this also allows for testing a large number of variants. So something that would be kind of fairly expensive with A/B testing, you could, like, for example, a message that you send out as like a push notification, you could test like 20, maybe 50 different variants, and the model would basically prune the ones that don't perform well very quickly. And anecdotally, I've heard that some of the variants that were originally thought to not perform very well actually turned out much better. So you can really take kind of like a data-driven approach there to what works and what doesn't at very little cost. The thing that we focus on mostly now is contextual bandits. So that adds, like, the multi-arm bandits just find a solution that works best across the board, but it doesn't account for maybe one message works better on the weekend and another works better during the week, or for different customer groups. So the contextual bandits take a context vector into account in kind of like deciding which variant to choose. And that's super powerful for all kinds of decision-making problems. You can use it for recommendations, pricing, or these type of applications.
I think that was the easiest to understand and simplest explanation for contextual multi-arm bandits that I've ever heard. So to the listeners out there, what Jonas just described sounds super trivial. Can confirm, having built several of them myself in the past, these are not easy to build. The devil is in the details to get these things correct. But it is super powerful if you can't figure it out, exactly as he said, where you can even set conditions where you say, I need you to determine, based on the context, what are the 5 conditions that match across these time horizons, and select the appropriate model at different times. And you can build that logic into it. So you can have a model for the weekend, a model for the first part of the week, model for the middle, and then a Friday model. And those can be all deployed, and then, traffic is allocated, and also put A/B, not the A/B testing, but you can also test different variants of those at the same time. But that's awesome. There's so few people that actually talk about building these systems. It's just awesome to hear that you guys are doing it. It is revolutionary how an implementation like these, how it enables you to move very quickly. So it's no longer you have to talk to the internal team that owns this part of the product or the part of the business and get their buy-in from doing a bunch of, shadow testing or something. And then convincing them, like, no, like, we've retrained this and it's better. Trust us. Okay, we'll allocate 5% of traffic for 6 weeks, and we'll see how it does. And then some executive will give the thumbs up. This way, you're just using math and statistics and saying, hey, we trust this. Let's just do it. And yeah, you can accelerate your velocity so much faster.
Yeah, absolutely. It was also surprising to me that I didn't find much blog posts or publications of like industry applications of contextual bandits or reinforcement learning. You'll find a lot in kind of research academic circles, but translating that to our types of applications is fairly tricky, because most of them use a simulator or a game engine or something like that, and you can have your agent play countless of trial and error runs in that environment and get up to speed. But building this type of simulation environment for our problems is typically not feasible, and then you have to actually interact in
Yes.
environment, and it is fairly costly. But it is super powerful that you just define a reward function that you basically tell your agent, your machine learning model to optimize for, and it figures out everything along the way. And this reward function can be very closely aligned to your business objectives. Again, in ride sharing, it's typically some kind of trade-off between number of rides and kind of like profits. So kind of like a growth versus profitability trade-off. And we have this kind of like with a knob in our reward function of the model, where we can say like, oh, now the business objectives change to growth, and the model, we tweak the reward function, and it will prioritize getting more rides over kind of like getting the highest price possible for the ride. And in supervised learning models, you get a prediction, but then there's this whole process of kind of like making sense of it and translating that into an actual decision, while that is all kind of like encompassed in the model itself.
Right. Yeah. So just a couple quick things. I used to work at Tubi, and an ex-Lyft data scientist was on my team, and he really guided a lot of experimentation that we did, and borrowed some ideas like surrogate metrics from Lyft, and also time split or switchback experiments, which was actually one of my main projects. So it was really cool to see you guys publish such cutting edge research, and you guys were up there for us. Netflix, because they were also a streaming service, we used a lot of their research. Google had some solid stuff. DoorDash amazingly had great experimentation. Then also Booking.com. Those were sort of our blueprints. So shout out for sharing all this information. It's really, really valuable to a lot of people. But one question out of personal interest, you said you have context vectors. When you're thinking about user segments, is that in your reward function, or is that in your context vector? Or is it not?
Right. So user information would be in the context vector, but it can be basically all kinds of features that would typically go into a supervised learning model. Anything you want the model to kind of take into account when making its decision goes into that context, which is like synonymous with features. And then you define the different actions that the model can take, which it's like typically a finite set of arms in this kind of multi-arm kind of analogy. And those can be like, if you have a pricing system, they can be like plus 3%, minus 3% type of like price adjustments. They can be like recommendations, like the different things you recommend. In the messaging example, they could be like the different text copies you send out. And then the reward is typically tied to some business metric that you want to optimize. It can be as simple as click-through rate, which is kind of the most immediate thing that's kind of easily to track, but it can be also like a financial metric, I don't know, some kind of revenue or like subscription signups or whatnot that is maybe a bit further removed, but takes into account some of the negative effects. Like if we raise prices, we'll reduce like follow-up requests from a user, and then kind of to kind of balance that out, the thing that you at the end of the day want to optimize is some financial business metrics rather than some click-through rate that maybe has some unintended negative consequences.
So how do you handle surrogates for late arriving data like that? Like if the business comes to you and says to both of you and says, "Hey, we want to deploy something that's going to look at um, whether our drivers manage to minimize their amount of downtime between rides that they're picking up something." I'm sure you have a much better solution than what I'm hypothesizing right now, but if you had something that they came up and said that, uh, what is the process that you use for helping them with that, with a solution like this?
With the reinforcement learning approach, or just in general, kind of like for this type of business problem?
For something that's relatively cutting edge research like the reinforcement learning aspect of it, what is your level of interaction with them? Because you've done all of this research and built all these solutions. If this team has no history or any prior capability of building something like that, do you interface with them and say, "Hey, I'll embed with your team for a couple months and teach you how to do this," or "Go read these papers that we wrote that explains it," or is it, "Hey, maybe you should try this older technology first, and then we'll talk about the more complex stuff later on"?
Yeah, I think typically for these type of problems, the company would go to the product teams directly rather than the ML platform team. Like, I think ideally we wouldn't solve particular business problems, but things have I feel changed also over the past, and what you described with embedding in the team, that's pretty much what I've done over the last half a year or so, that we built these reinforcement learning capabilities, and there wasn't as much expertise in the company, and we built kind of like little demo models and templates and whatnot, but it's not necessarily enough to kind of really get up to speed on it. And we had one like very impactful application, and then we decided, okay, I just basically join the team mostly and work closely with them. And kind of the things I've learned by kind of building the system, how to, like, one of the trickiest things is to actually evaluate how the model is doing, because you don't have labeled data, you don't have ground truth. So your model just does something and you have to kind of figure out if it makes sense or not. So a lot of techniques with reward estimations and off policy evaluation and things like that. And that's where I kind of like supported the team. And we used to have a team called Applied ML that had that model kind of year round. It was kind of a team of ML engineers that would embed with the teams, work on a project almost kind of like on a consultancy basis, and then jump onto the next project. And that was kind of my role over the last couple of months, being like embedded in the team, working closely with them, getting them to a successful experiment. And then, but ideally on a platform team, we want to kind of leverage our tools to many teams. So while we do kind of like these one-on-one engagements, we can't do that as much. So I think for a temporary basis, that's okay.
Yeah, I can add a bit here. So like from our standpoint as an ML platform team, what we care about is developing new types of capabilities. And so I think, when Jonas and I were first starting out, Lyft already had kind of like general sort of like supervised learning capabilities. But our goal was to expand that. So like we talked about kind of like the custom model wrapper code. And then we've also been adding new sort of like flavors of capabilities, like the reinforcement learning types of models and real-time ML models that leverage streaming. And so for us, really, like when we try to build these capabilities, the first thing we do is we find a few alpha customers. And so these are typically like product teams that are committed on their roadmap to also using these capabilities. And we found that having like definitely like more than two, like 3, 4 is what we want to target if we're going to build something, because I think over time, like some of them don't work, some of them drop off, and so it's good to really have some built up demand for a thing that we're building. And then our process is usually like with the alpha customers that we identify, we build our platform components across training, across serving, across monitoring, and we work really closely with them. And we kind of like look into the application. We look into sort of like the metrics that we're trying to drive, and then those are the ones where we're more embedded with the teams. But it's always a collaborative process. Like we're not really the team that's like driving the business metrics, say on like ETAs, or like the business metrics on pricing. And so we're always working kind of with like the management of those teams, or with data scientists and engineers on those teams. It's just with the alpha users, we kind of iterate on the platform as they're building their use case, because it's a brand new use case. And then afterwards, once we bring kind of like those projects to completion, then we have kind of like a beta phase and a GA phase. And by the time we get to GA, we kind of assume that the component is stable. Like by GA, we have like multiple kind of like use cases in production. We've like ironed out a lot of like the issues that we've found, and we usually have like strong customer facing documentation. So we assume that a team with very minimal kind of time from our team can onboard to this new capability. So by the time we kind of get to GA, we assume that there's enough sort of like precedent and enough functionality and enough knobs and documentation that a team can just come in and build, say, a new RL model.
That's a really smart way of doing it. So you figure out from the first engagement what your requirements are, build a prototype, and then you dog food it, because you're basically embedded with that team. You're having to use your own framework to make sure that it works. And then that next alpha customer, air quote, that you're gonna be interfacing with, you're dog fooding what you built like during that first engagement with the first team. Yeah, I mean, it's a fascinating way to approach building infrastructure. It's kind of how a vendor would do it. That's how we do it at Databricks. We build some alpha feature and find a couple of lighthouse customers that you're going to feel their pain basically while you're building it, and saying, that's totally broken, I need to fix that. Or, wow, I have no test coverage for this failure mechanism, I better go back and fix that. So, and then continuing in that beta phase where you're like, hey, this is in preview, but we're going to change some stuff if we need to. And then once it's GA, you're like, all right, it's version locked. It's painful to change an API. Do you find it easier? Because you guys have worked at a number of companies before Lyft. Do you see that it's sort of the environment is a little bit different due to the way that you've chosen to build this team, and how you both have sort of crafted it about adopting these philosophies? Do you find that very different than how it is at other companies that you've worked at before? Because it's almost unique. I'm telling you, like I've talked to a lot of very large, customers. I used to be in the field doing what Michael does, where I was interfacing with, Fortune 100 companies, and you get to see how the engineering teams work internally. And a lot of them, like the service level for ML engineering, they're so siloed off from everybody. They would never embed with an organization within their group. They're there as like, hey, we'll deploy your stuff only if it works, and we'll tell you when it breaks, but that's about it. But you're approaching development of features like a modern software vendor would.
Yeah. Well, I'm glad that, it seems like we're doing things right if we're doing them in the same way as, like a great vendor like Databricks. So that's awesome. I will put like a caveat here that, I've worked at Amazon and Stripe and Facebook and Instagram, but those were all internships. And then Lyft has really been my first full-time job. So I've been here for 5.5 years now. But I think kind of like the process that I described, it's something that we didn't really start out with. It's something that we kind of learned and adopted as we've rolled out a few different sets of capabilities. We found that this is what works. I mean, like some of the comments I made, they stem from failures that we've experienced.
Mhm.
Like we've kind of tried to ship things where we have like one alpha customer, and then we found like, that alpha customer reprioritizes, or like maybe like we run an experiment and we can't really show the impact, and then we realized that we probably shouldn't have invested a quarter in building a certain type of capability because we just didn't validate the demand for it. So
Yeah. Been there. I mean, it happens even to really good vendors. Like we build stuff that we throw away,
yeah.
But what I'm so fascinated with when you said that, like, hey, you worked at internship at the big companies. This is your first job, and you mentioned that this just seemed natural to do it this way. So if you came to that conclusion, the two of you and other people on your team, just by experimentation, effectively,
Mm.
I'm just wondering how that's even possible without somebody coming in and being like, listen, this is how it's done at, you know, this entire industry. That knowledge of what you've learned through experimentation and validation through hypothesis testing of this is the way to build software that actually works, even though there were failures along the road. I mean, we all do that. We all have those failures and we learn from them and adapt. But it mirrors so perfectly how, you know, unicorn startups do their you know, their vendor interfaces with
Mhm.
customers to develop their platforms.
Mhm.
So either you guys are geniuses or it's an inevitable result of smart people trying things and learning from them and then optimizing.
Yeah. I think what I would imagine happened is like these three categories of like alpha customers, beta customers, GA customers. They are maybe like I'm sure we didn't invent them. Like
Right.
we kind of just like came up with like the fact that we have three buckets and they happen to be named that. We probably learned it from like a blog post or from someone that had prior experience. But I think some of the insights about like what defines an alpha phase and how to operate on our particular team, there are things that we started with like a direction, like the alpha customers are the first ones that you're building the product around, and then I think over time, like individually and as a team, we've just learned some like life hacks for how to approach these phases.
But they're the exact same life hack wisdom that multi-billion dollar valued vendor companies use internally for developing for their entire product with like, hey, there's 3,000 engineers working on this product. This is how they do it as well. So it's just fascinating to me that you guys came up with this of like using this. You've learned it in such a short period of time, though. 5 years is a short period of time to learn. Like this is the proper way to build stuff by talking to people and then dog fooding it and living through. Does this implementation work? And
Mhm.
because a lot of groups that do what you guys do at companies, they get the product requirement list from a PM
Mhm.
and they say, hey, here's what we need this feature to do. And you read through it and you're like, okay, there's like 800 things on here. We don't have time to build all this stuff. Here, okay, we'll arrange stuff and you figure out prioritizations and you're like, all right, these are P0, we got to get these done. Some P1s, and then the rest of this is just P2, which means we're not we're not going to touch it. And then you build it, deliver it, even if you are using, agile methodology with frequent deliveries and stuff. But because those silos exist and the people on that team are either uninterested or too afraid to go out and talk to these other teams and say, can I build this with you and make sure that this works? And let's play some jazz and figure this out. Um, they end up shipping stuff that team then gets dumped in their lap. And they're like, this isn't what we asked for at all. And this sucks and it's broken. And then they churn and they move to another team to build some other product for them that takes a year and a half to develop, and that sucks as well. So they stagnate. And that's what I said at the beginning of this, where it's like, hey, those big companies, they have like less than 10 models in production. But I think the thing to take away from our discussion, the biggest thing, is that the team that you guys are on, you're the ones that enable those 400 something models because of how you attack your platform problems. I think that's the core of it. And that can also apply to ML teams as well. People building models, talk to your customers and work with them and use this same phase of like, hey, I'm going to work with 4 or 5 people and make sure that this idea actually works. And then we'll bring it to a bigger group and make sure that everybody has buy-in. But yeah, I just applaud both of you. It's great.
Yeah, I think our engineering culture is definitely very collaborative. And you even mentioned the PM. Like we typically have the PM embedded in the team. We had a PM on ML platform, and we would create these PRDs together. I think we're also kind of like at a sweet spot of the size of the company. We're like big enough that we have a really great infrastructure team, data platform team that kind of build the foundations that we sit on top of, and they make it very easy to push a change out to all of these repositories and kind of take the pain out of some of these collaborations. But we are still small enough that there are not layers of abstractions and hierarchy that we have to work through, but we can work directly with the customer teams, and we need to be scrappy enough to like, okay, let's just get together and get this done. We don't have like these billion-dollar budgets in like siloed organizations or things like that, where there's actually some urgency in kind of like getting the things done.
Yeah, I think another probably difference between working at a vendor company like, Databricks versus Lyft is just the flexibility of timelines, honestly. Like I think that if you're a vendor, you kind of say like we want to ship this in February, and that's kind of what you've communicated out to your paying customers across the industry. Whereas at Lyft, it's kind of driven. It's more of like, like an agreement amongst engineers that like we will deliver this feature in Q1, and so I think one of the consequences of kind of having more like, like friendly collegial relations with the people that you're delivering things for is that you don't need maybe as much sort of like PM or like timeline or like management overhead. You can kind of just work with those people directly on building whatever it is that you're working on. That makes sense.
Yeah.
Definitely.
Totally.
So I have one more topic before we close. And the setup for the topic is often when you are listening to a podcast, you sometimes forget that the people talking are actual people. They have lives, they have families, they go do stuff. And after looking through your guys' background, you guys have made a variety of transitions. I'm part of that group where that has made a bunch of transitions. Ben has made a lot more than all of us combined, probably. But I was wondering how you guys thought about fostering growth, and what are you guys excited about currently in terms of developing a skill set?
I can comment right now. I think the thing that I've been trying to do after we've built kind of a number of different capabilities in our ML platform, like the serving stuff, some of real-time ML streaming stuff, some RL stuff monitoring. I think now what I'm looking to do more is working with the marketplace teams at Lyft to kind of standardize and consolidate all the different pieces of ML infrastructure. So we didn't really get to touch on this, but like even though our ML platform was built in 2018, 2019, and it's been adopted by most of the users at Lyft, there's still like pockets of the company that don't really use kind of our standardized set of ML components. So teams have gone off and like built their own, say, streaming pipelines for computing real-time features, and they've built their own even like model serving services that don't use our kind of like standardized framework. And so kind of understanding the history behind those things and then trying to standardize those so that the whole company is kind of running everything in the scope of ML uniformly. And then also through that process, like really understanding what those models do like deeply, and like how they're trained and like the different trade-offs and the business metrics. I think that's a priority for me at the moment, and it's something that I'm really hoping to like make progress on in the next half or so.
Awesome.
Yeah, I think it's easy to kind of get bogged down in the day-to-day of kind of like in a platform team. There are always operational concerns and kind of work on the stability and reliability and tech debt and all of these things of the systems that you maintain. But it's good to have, I don't know, one more kind of creative topic that you're curious about. For me, it's been the reinforcement learning over the last couple of months, and just have something where, I don't know, you enjoy going through some online classes or read about it, or something that kind of like stimulates that part of your brain that kind of keeps you growing rather than just kind of like operating on kind of like autopilot in the day-to-day work. But yeah, there's a balance. Sometimes the balance is not within your control, but I think having something to kind of like go back to is really important.
Yeah, that makes a ton of sense to me. I mean, just for symmetry, Ben, do you want to chime in as well?
I like Jonas's answer, and I agree 100%. Particularly if you're, full-time software engineer and you're supporting something that a lot of people are using, that day-to-day can become kind of like what you said. It's almost like autopilot. You're like, hey, I'm responding to issues, I'm fixing bugs, I'm filing these small changes to the repository or to the repositories, and it can get monotonous over time because it's really just sort of the same thing. So having projects, so that's one of the things that we try to do with work planning within our teams, is making sure that the distribution of our quarter is giving some exciting stuff for people to work on, where they get a break from the day-to-day. Like, hey, you're not on call for this entire sprint on anything, and all you're doing is just like draft a design doc, and then 3 days later, after it's approved, start implementing this cool thing. And when somebody gets that, they know, like, hey, I've got 3 days leading up to doing the design where I just get to figure this out and be creative and learn all this new stuff. And it's like a refresher that happens, and it keeps people excited and constantly learning new things. So yeah, 100% agree.
Sweet. All right, so I will quickly summarize. A lot of really good high-level information specifically about Lyft's infrastructure, but some things that stuck out to me is some core areas of growth since 2018 was their support of real-time modeling, model serving in general, and then non-supervised methods, not specifically unsupervised, but just non-supervised without a label. And that took a variety of really interesting forms. Some things that they're still struggling with are experiment tracking and also feature stores. And then it seems like the high level takeaway of this episode is that if you're an internal infrastructure team or just developing things for customers, try to embed with your stakeholders. Find an alpha customer, find a champion that will give you really good real-time feedback and feel their pain. Find their issues and try to solve them sort of in an iterative fashion. And again, that's how Databricks works, and that's how Lyft works. So, Konstantin and Jonas, if people want to learn more about you or your work, where should they go?
Yeah, I think you can find us on LinkedIn. Another, like, if you want to learn more about our systems, I recommend our engineering blog, eng.lyft.com. Actually, a lot of the components we talked about have dedicated posts there. I try to add one about the reinforcement learning by the end of the year as well.
Please do. I'm looking forward to reading more about that.
Yeah, and I mean, +1 to LinkedIn. I love new friends and connections, so please reach out if you want to follow up on anything that we talked about here.
Amazing. All right. Well, until next time, it's been Michael Burke and my co-host.
Ben Wilson.
And have a good day, everyone.
We'll catch you next time.